Okay, we're on problem number 15 now, and they're really, these optional problems are killers. I mean, they really are. So put this one over here. I'm seeing 0 pi, and then I see x times sine x, and then I see 1 plus cosine squared. And granted, even if you're experiencing integration, you look at these things and you wonder, can I find that guy's antiderivative? And I'll be honest with you, you would struggle with this for quite some time. And I'm going to say, I don't think you'll find the guy's antiderivative, right? So someone's going to say, what would you do over here? And I want to just go through this briefly. This is an exam that was given to high school students. At least I believe it was given to high school students. I can't read Mandarin, but it's in Taiwan, and it's for their top school there. It's called I think it's called the National Taiwan University. And this was on the entrance exam. So this would be given to a high school student, and they have a series of questions, not just one question, a series of questions. And some high school students are better than others, by the way. Now, granted, some tricks are taught in other countries that are not taught in the United States. And one of those rules that's typically not even mentioned is King's rule. Now, in other parts of the world, they just do, hundreds of thousands, I'm exaggerating, but they do a lot of rules, right? Virtually, the kids are told rule after rule after rule, and they're looking at things and saying, I wonder if a rule applies to this. And, King's rule, I'll go through it with you, but it says something over here. I'll write down what King's rule says, briefly, by the way. A to b, f of x, dx would be identical to this over here, a to b, f of a plus b minus x dx. Well, you know what? I want to briefly go through the derivation of that and see what happens over here. I'm going to look at this. I'm going to make a u substitution, and the u substitution would be a plus b minus x. What would du equal? Du would equal minus dx. So let me write this down. I'm looking at the right-hand side, and I'm going to do the lower limit. And the lower limit, what am I doing over here? It's a. I just replace it over there. So you're just going to get b now. All right, I'll write that down for you. Now, if you do the upper limit, which is b, and you plugged it in here, you would just get a, right? And then what do you get over here? You get f of, well, a plus b minus x, I said was u. And then dx is equal to what? It's equal to minus du. All right, this is looking pretty good. I'm going to rewrite this what I understand. I'm going to say this is equal to, well, it's minus that, so I'm going to reverse the limits. It's going to go from a to b, f of u, du. And what you could do now is do a very simple substitution. Say u is equal to x, du is equal to dx. And what would you get? You'd get a to b, f of x, dx. So we just verified King's rule, by the way. Now someone says, big deal, you verified that. I want to use it. All right, I want to use it on this thing over here. So I'm going to be using King's rule on this guy over here. And let me go through that with you. I'll write it down for you. And again, certainly when you're doing these problems over here, you might say, if they didn't give me King's rule, would I be able to figure that out? I'm of the opinion you should be given King's rule, that you shouldn't be memorizing a bunch of rules. Somebody says, oh, King's rules applies to this problem over here. Well, let's see how it applies. I'll put this over here. So 0 to pi, x sine x, 1 plus cosine squared, x dx. Well, let's put King's rule down. So I get 0 to pi, and then I'm going to plug it in. So this is the function f. And what do I write down? I'm going to write down, pi minus 0 minus x, which is just simply pi minus x. All right? Again, what am I saying? Pi minus 0 minus x, which is pi minus x. So we'll put this over here. Sine pi minus x. What goes on bottom? 1 plus cosine squared pi minus x dx. Now, granted, someone's going to look at that and say, that made it like 1,000 times worse. Not really. Let's take a look at that. I know some basic stuff from trigonometry. And let me write this over. Sine pi minus x. Well, I'm going to expand it. There's other ways of doing it. Don't think that's the only way of doing it. I'm going to say sine of pi times the cosine of x minus the sine of x times the cosine of pi. All right, I think I did okay there. What's sine of pi? It's 0 times cosine x. This is going to be minus sine x. And what's cosine of pi? Minus 1. Well, lo and behold, this is just equal to sine x. All right, that's an important fact, by the way. So I'll take care of that later, but right now I'm going to do the cosine of pi minus x. And again, stuff I learned in trigonometry. So cosine pi, cosine x, plus sine pi, sine x. Well, the cosine of pi is minus 1. That's cosine x. Plus the sine of pi is 0, sine x. And there's other ways of doing this, by the way. What do you get? You get minus cosine of x. So what I want to do is I want to go back and just rewrite the problem again. I just derive some things over here. So I'm going to say 0 to pi x sine x over 1 plus cosine squared x. Using King's rule, what I find out, 0 to pi minus x times a cosine, not cosine, sine pi minus x, what goes on bottom, 1 plus cosine squared pi minus x dx. Well, we just discovered something. Let me write this down for you. 0 to pi, this would be pi minus x, not much I can do about that. But the sine of pi minus x, we just did it, was just something like the sine of x. Let me do the bottom, sorry about that. It's 1 plus, well, here comes my problem now. And what do I got? I have this over here. Well, I hope you realize that if you brought that down, you squared it, what are you going to get? You're still going to get cosine squared of x. Again, what are we doing? We're squaring that, all right? That this thing is the same thing as cosine of pi minus x. So if you were to square that, the cosine of pi minus x, if you were to square that, would just simply be cosine squared. Really convenient. So someone says, does that help you? A little bit. All right, so let's write this down over here. I'm going to split into two integrations now. The integration I'm seeing is 0 to pi sine x, and then what do you get on bottom? 1 plus cosine squared x. This is dx. And then it's going to be minus, it's going to be 0 to pi x sine x, 1 plus cosine squared x dx. And what does that equal? It equals this over here. That's pi. Sine x dx, 1 plus cosine squared x. So I want to point out what I'm noticing about this over here. And again, you might say it's all over the place now. But what I notice is that this guy here and this guy here, I can bring it to one side now. What would you get over here? You get 2. You get 0 to pi x sine x over 1 plus cosine squared x dx is equal to, and actually an easier integration problem. I'm going to pull the pi out though. And that's going to be sine x and 1 plus cosine squared x dx. All right? So I'm going to say right now, I got an integration that I'm going to say I think I can handle that one. And why is that? It's clearly a u substitution problem. Let me write this down. I'm going to let u equal the cosine of x. What would du equal? Well, du would equal minus sine x dx. So let me write this down. I get pi. By the way, this is equal to 2, 0 pi x sine x over 1 plus cosine squared x dx. So I get pi. Let's do the limits of integration now. Now, if x is 0, the cosine of 0 is 1. If x is pi, the cosine of pi is minus 1. And what do you get over here? Well, let's take a look at it. Du would be minus sine dx, so it's really a minus of a du. I'll put this over here. You just put the minus on the outside. What goes on bottom? 1 plus, well, it's going to be the cosine squared, which is going to be u squared. All right? I'm going to write it a little bit differently, and I'm going to write this as pi. And I can write this as minus 1 to 1, just reversing the order of the integration with the minus sign there. And then it's going to be 1 over 1 plus u squared du, which should be recognizable to you. What's it going to be? Pi, and it's going to be arctangent of u. Limits of integration would be minus 1 to 1. Let me go through that with you. You're going to get pi. You can get arctan of 1 minus the arctan of minus 1, which is going to be pi. The arctan of 1 is pi over 4, minus the arctan of minus 1 is minus pi over 4. Right? I want to lose sight of this. And when you get over here, pi, and you get pi over 4 plus pi over 4. And what do you get there? Well, looking at it, it's pi, 2 pi over 4. I think I could simplify that. And what does that give me? Pi squared. Let me make sure I'm doing that right. Yeah, pi squared. 2 goes into 4 2 times. I want to point out this is equal to 2, 0 to pi. Let's go back up there. X sine x, right? dx, 1 plus cosine squared x. All right? So what do I got here? I think I know it now. So what do I'm going to do? Divide both sides by 2. We'll check the key in a moment. And this gives you pi squared. If I divide both sides by 2, that would be 4. My final answer. Look at the key, and certainly when you look at the key, I know there's work down there. A lot of times, even though work is written, people don't understand the work. Someone has to talk them through it. And granted, I'm not saying that any one person can talk you through that. You may have to talk yourself through that. But anyway, do I get the right answer? I got the right answer. We're good to go to the next questions. Thank you.